So you're getting ready for a tech interview. You know there's one topic you absolutely cannot, under any circumstances, avoid: data structures. The thing is, where do you even begin? It can feel overwhelming, right? Well, don't worry. We're going to dive into a clear, step-by-step roadmap that'll take you from the absolute basics all the way to the complex stuff the big tech companies love to ask about. I just love this analogy, because how true is that? Data structures and algorithms, you'll hear it called DSA, they're the essential filling, the absolute core of any technical interview. You just can't have one without the other. This isn't just another topic to learn, it's the foundation that everything else you do will be built on. Okay, before we even look at a single data structure, we have to establish the golden rule for this entire journey. Seriously, this one principle will save you so much frustration and so many headaches. You have to master the logic before you even think about writing a single line of code. Here's what you're going to do every single time. First, you grab a pen and paper, no keyboard. You work through the problem, you draw out the boxes and arrows, you build the logic, and you really get how the data is supposed to move and change. Only when that logic is rock solid in your head, only then do you move to a language like C++ or Java. Remember, coding is just the syntax. The real heavy lifting is building that logic muscle. All right, now that we have our golden rule, let's get this roadmap started. Every single journey into the world of data structures begins with one fundamental building block. And here it is, the array. It's a simple idea, but it's so powerful. It's just a collection of items, all stored right next to each other in memory, like a row of mailboxes. This is the bedrock for so many other complex structures, so whatever you do, do not rush this topic. You have to get this one right.
So what does it mean to master arrays? Well, you got to get really comfortable working with 1, 2, and even 3-dimensional arrays. You need to understand how the computer calculates an element's address, and you got to master your basic searching and sorting algorithms. And here's the key. Arrays are the direct foundation for other important structures like stacks and queues. So if your array game is weak, everything that comes next will be too.
Okay, so if arrays are so great, why do we need anything else? Well, this table tells you everything you need to know. Look at that fixed size part for arrays. That's their big weakness. They can be really inflexible. And that exact limitation leads us right into our next major topic, which was invented to solve this very problem. And that brings us to the linked list. Unlike an array, the elements in a linked list can be scattered all over your computer's memory. They're all connected to each other using pointers. This gives them amazing flexibility to grow and shrink as needed. And that is exactly why linked lists are an absolute favorite in technical interviews. Now, when you're studying linked lists, you need to master the main flavors: singly, doubly, and circular. But the most important thing, you have to practice the fundamental operations: insertion, deletion, and reversal, until you can do them in your sleep. These problems are classic interview warm-ups for a reason. Okay, once you've truly nailed arrays and linked lists, you've got the raw materials to build more specialized data structures. Now we're going to look at how we can organize information for specific jobs, focusing on stacks, queues, and the incredibly fast hash tables. You know, stacks and queues are just beautifully simple concepts. A stack is like a pile of plates. The last one you put on top is the first one you take off. That's last in, first out, or LIFO. A queue, well, that's just like a line at a coffee shop. The first person in line gets served first. First in, first out, or FIFO. They're simple principles, but they have incredibly powerful applications. And speaking of applications, stacks are used everywhere. They're used for everything from solving math problems to the famous Tower of Hanoi puzzle. But that first one on the list, recursion, that's huge. The way your computer manages function calls is literally with something called a call stack. Understanding this is a massive level-up moment for any developer. So what happens when you need speed, like blazing fast lookups? That's where hash tables absolutely shine. By using a clever trick called a hash function, they can find data in what's essentially constant time. That means it takes the same amount of time to find an item whether you have 10 items or 10 million. When you need to get information instantly, this is almost always the answer. All right, you've built a really solid foundation. Now it's time to level up and tackle the non-linear structures. These are the ones that separate the candidates from the new hires at places like Google, Amazon, and Microsoft. This is where you really set yourself apart. So we're moving from straight lines to branching paths with trees. A tree is all about representing a hierarchy. Think of a family tree or a company's org chart. It's made up of nodes, and it all starts from a single root node at the very top. And trust me, trees matter.
The big tech companies love tree-based questions. You absolutely have to know binary trees, and especially binary search trees, which keep data sorted for you. You'll also need to know about self-balancing trees like AVL trees and heaps, which are crucial for things like priority queues. And of course, you have to be fluent in all the different ways to travel through them.
And that brings us to the most flexible data structure of them all, the graph. If trees represent strict hierarchies, then graphs represent complex networks. Think about it. A social network like Facebook is a graph. The internet is a graph. Your city's road system is a graph. Anytime you have a bunch of things that are all interconnected, you can probably model it as a graph.
Now with graphs, the focus really shifts to the algorithms you use to explore them. You have to know breadth-first search and depth-first search inside and out. But for those top-tier roles, you'll also need to understand concepts like backtracking to solve maze-like problems. And of course, the classic shortest path algorithms like Dijkstra's, which is literally what Google Maps uses to find you the quickest route.
So that's the roadmap, from the simplest arrays all the way to complex graphs. But knowing the path isn't the same thing as walking it. So let's talk about the final and most important piece of the puzzle. How do you actually master all this and walk into that interview with total confidence? Well, it really all comes down to one number, 6, as in 6 months. According to the experts, that's the kind of commitment it takes to go from just being familiar with this stuff to becoming a real pro.
And here's exactly how you do it. It's a simple plan. Dedicate 1 hour every single day, just to the theory and logic of data structures. Then another hour every single day to actually solving problems with algorithms. 2 hours a day. That's it. That's the price of mastery.
And there it is. It's not about cramming for a week before an interview. It's all about the compounding effect of consistent, daily effort over several months. That's how you really build the intuition and the problem-solving muscle you need to succeed.
So the roadmap is all laid out for you, from arrays all the way to graphs. The path to mastery is crystal clear. The only question left is the one you see right here. What is the first topic you're going to tackle today?